Welcome back, viewers. In this video, we're going to discuss some stunning facts regarding agriculture, how there are various researches done, and how those facts are amazingly proven, and how they're applicable in farmlands, and how farmers can be benefited from this fact. So let's dive in this video. How insects sense unhealthy plants. There are several research on this topic that how insect can sense unhealthy plants and how insects will leave healthy plants behind and will constantly attack those unhealthy plants. So plants constantly communicate with electrical signals and insects are tuned to those signals. How insects are attracted to some plants which are unhealthy and not to other plants. How olfactory senses works and how insects are attracted to the some regions of the farm and not other regions of the farm. Insects smell with their antenna as well as with their palps. So when they fly or when they hover through the farmland, they tend to pick up various odorants from the air. These odorants are released by plants, which are healthy as well as unhealthy. And these odors are applicable above 0 degree Kelvin. So we know that Indian peninsula is always above 0 degree Kelvin and not in polar above mountainous regions I would say, but in Indian subcontinent we have an average temperature of 25 to 30 degrees Celsius. And this electromagnetic vibrations which are detected by insects, they have various sensillae on their tiny antenna that get tuned to very particular frequency, and this particular frequency are important for insect to detect the unhealthy plants. So there the antenna has various palps in them and which can recognize this olfactory senses, which can these are olfactory senses of those insects, and this can detect the odorants which are released by healthy as well as unhealthy plants. There are certain floral compounds given off by the some insects which are going to be attracted. For example, honeybee. Let us consider honeybee. Honeybees are always attracted to the pollen. Honeybees are attracted to nectar-rich plants, I would say, and their main work is to officially consider with pollen, but they are attracted to rich nectar-rich plant. Nectar rich plant. I mean, not that honeybee want attracted to the low nectar plant, but they will hover over that plant less as compared to those with the plants which are having high amount of nectar. And there are some plants which enunciate themselves as unhealthy. And when they picked up by the insect, insects are most prominently get attracted towards the unhealthy plants. Unhealthy plants are easily digestible in insect gut bacteria. The healthy plants and their carbohydrate profile and their sap or their Brix level is quite high in sugar of healthy plants, whereas unhealthy plants have quite low Brix level. Brix level is actually the sugar contained in the sap, as well as insect cannot digest this healthy sap. The plants cannot digest this sap which is associated with healthy plants, and they by doing so they get injured. If they attack unhealthy plants, they will get injured. And insects always attack. Remember this one thing: insect will always attack unhealthy and injured plants. The plants which are like injured, or I would say if there are some farm operations which are conducted and which make the plant injured or make the plant bleed through its sap, insects are only going to attracted to those plants. There is a concept called Brix, which I already explained. Brix is measure of sugar, vitamins, minerals, protein, and other solid content in the plant juice. What is a plant juice? Plant juice is basically its sap, which oozes out when you cut a plant, or which is flowing through the plant. And when you get plants above 12 Brix level, Brix which is the sugar level, insect don't really bother to cause issue to your plants. So Brix is actually a measurable unit which detects the sugar level and minerals levels in this plant. And when the Brix level is high, about 12, insect really don't cause any harm to those plants who have Brix level about 12. Unless they just want to rest on them, they will sit on that plant, but they won't feed on that plant because they know that plant is really harmful for them. They cannot digest such plants. They will starve themselves, but they will not digest to, or they will not eat those plants which are about 12 level of Brix. If insect takes bites of such plants, they won't be able to digest through their cuticle in their phloem, and this kinds of plant aren't really easily digestible to them. Our digestive systems are designed to eat healthy plants. Of course, we cannot eat unhealthy plants, whereas insect digestive system is not designed to eat healthy plants. It is designed to eat unhealthy plants. You can take a potato beetle. This is an example. Put it on an healthy potato plant, and it won't be able to digest it. But if an unhealthy potato plant is have got certain visible frequency, that insect can detect from a long distance, and insect will hover over over that potato plant, and it will feed on that plant. And these frequencies are detected by, as we discussed earlier, by their antenna and as well as their sensory. How farmers can be benefited from this? Let's discuss that one. Where certain compounds insects are attracted, which can be managed. Farmers or a scientific researcher can manage these compounds, and what unhealthy plants emit is basically ethanol or other alcohol compounds. Why ethanol? Because these plants are already degrading, in the stage of degrading. Unhealthy plants are in the stage of degradation, or they are getting fermented. When plants are getting fermented, they release ethanol or alcohol, and that's why insects are able to see or sense through their palpi or through their antenna. And this is how, with the help of brisk level, as well as with the addition of all these tactics, we can really improve the brisk level, and we can eliminate those sap sucking insects, or which insects are basically causing harm to the plants. Let's move. Okay. Now, the next fact is all about the presence of soil-borne disease infection is not correlated to the presence of infectious organism, but due to the absence of suppressive microbes. What this what this fact or what this research is actually trying to say, that the soil-borne disease pathogen is already present in the soil, or already present in the farm. What is actually absent in the farm is actually disease suppressive microorganism, or disease suppressive microbes, which were inhabiting in the soil, but which are currently eliminated due to our practices, due to our unsustainable farm practices. Disease and insects are Mother Nature garbage collector, getting rid of bad stuff, the weak plants. Yeah, this is quite amazing. I would say quite an amazing quote, that diseases and insects are Mother Nature garbage collectors, which are used to get rid of the unhealthy stuff. Consider it in terms of COVID-19 as well. Okay, ignore that thought. If we have Pseudomonas bacteria in the soil, they act as a regulator in soil. They will attack the pathogenic fungi and can arise. So Pseudomonas is kind of disease protectant bacteria. It is a disease suppressive microbes which can regulate the pathogenic fungi. But when we apply glyphosate, which is an herbicide, it is a broad spectrum systemic herbicide, which intends to kill Pseudomonas bacteria, which is an beneficial microorganism. So when we apply a herbicide, which is a glyphosate, to kill herbs, unwanted weeds, we actually tend to eliminate the important bacteria, which is Pseudomonas, which is a disease suppressive microorganism, and which is really beneficial for soil. But if we apply glyphosate, we have no protection against our soil, and our soils become, or they tend to be susceptible to this disease causing pathogens. Pseudomonas are effective when we use ammonia rather than nitrate fertilizer, which actually lower rhizosphere pH. Pseudomonas, when we use nitrate fertilizer in the form of urea, or in the form of all salt soluble fertilizer, when we use those fertilizer, so they tend to kill those Pseudomonas bacteria, or they tend to limit their population. What we actually can do is we can use ammonia, which is NH3, as a form of an fertilizer that can actually make a favorable pH for the Pseudomonas, and it will be effective for this pH as well. Now, if we have a huge population of Fusarium, which is a soil-borne fungi, or a pathogenic Pythium or Phytophthora in our soil, which is present from the previous crop, or which got born in a disease by natural implementations. So, if we have a natural balance between Pseudomonas, which is a disease suppressive microorganism, and this Pythium, which are disease causing, we can actually eliminate the bacteria. We can actually, with our this Pseudomonas will actually clean the soil right up if we have their natural balance altogether. As well as when we apply anhydrous ammonia or salt-based fertilizer, they act as an oxidizing agent which will eventually kill the microbial community and which will reduce the population of Pseudomonas or other disease suppressive microorganism, and which will eventually increase our problem and which will cause fusarium or other disease causing soil-borne fungi to increase in population and even make this scene or make the scenario more worst. Also, the micronutrients which are essential for disease suppression, they get easily chelated when we apply pesticide or when we apply herbicide. They get easily chelated up or they get locked up. As they get chelated, they get tie up in the soil profile and not are not in plant available form. As we as we apply this insecticide or as we apply this pesticide or herbicide, we tend to tie up those micronutrients and which are actually helping the plants in disease suppression, where and they will not be in plant available form, and therefore the suppression or therefore the susceptibility of plant towards the disease will increase. As well as the Shikimate pathway, which is a seven-step metabolic pathway used by bacteria, archaea, fungi, algae, protozoa, and plants for biological folates and aromatic amino acids. This pathway is basically an important pathway for plants and all other protozoa, microorganisms, fungi, and bacteria. This pathway is really important. And when we tend to apply glyphosate or when we tend to apply pesticide, fertilizer, insecticide, this pathway tends to be blocked or they tends to block this pathway or they tends to cause suppression of this pathway. As well as uh, now if magnesium, which is a micronutrient, is in a chelate form, which is not in a plant available form, cannot be absorbed by the plant and is responsible for shutting down the Schmitt pathway, which we discussed earlier, and which is really important for plant and which tends to increase plant susceptibility to a disease. The pathway is actually like a plant immune system, how we have our own immune system, which protects us towards any diseases or which protects us from certain viral infections or certain envelope diseases. This pathway is actually the immune system, same for the plant. And if that gets blocked, the disease susceptibility of a plant will increase. And if we shut, and this pathway is actually shut down. This pathway is basically degraded by the application of fungicide. Disease will start invading, and the overall plant health will deteriorate, and the cycle goes on continue. And this is how farmer can lead losses in their income or will loss in their yields. There is this study which says that cobalt to inhibit ethylene production increases yield and improves storability. How application of cobalt is actually important in increasing the yields, improving the storability or increasing the shelf life of a plant product, and how it can suppress ethylene production. Cobalt is an undervalued micronutrient or unused nutrient basically. If we don't manage cobalt properly, it will cause us yield and storability. It is like costing a lot of it. When plants contain adequate level of cobalt, ethylene production is inhibited. We know how ethylene is a plant hormone which affects its growth, nodule elongation, speeding up senescence. Senescence, which is the final stage of plant development, which speeds up by the ethylene production. Seeds tend to mature faster in response towards ethylene. Ethylene increases node length. When we have ethylene is actually responsible for plant growth in terms of node length, in terms of elongation, in terms of senescence. But when we have an adequate level of cobalt, node will be shorter. Node length of a plant will be shorter. This will lead to a shorter plant health and they will be stocky, sturdy, and will have more nodes per inch of crop height and will carry a heavy crop load. Now, if we suppress the growth and if the plants are stunted, they will, instead of focusing on the vegetative growth, they will focus on the reproductive growth. and which our main focus is actually generating a higher reproductive growth. So, and therefore they will have more nodes per crop height, and therefore they will carry a heavy load of yields. Ethylene decreases the number of flower buds as well as fruits. When we have an adequate cobalt, there will be suppression of this ethylene production, or cobalt will actually regulate the ethylene compound, and how we can increase the number of flower set, or how we can increase the number of fruits or buds in a plant. How even application of ethylene, how even application of cobalt can lead to a node, and can node elongation, and can lead to a higher fruit count. Now there was an example which says that on soybeans, if all nutrients were managed efficiently and cobalt is also managed in terms of spraying, we can have 10 to 12 pods per node instead of 2 to 3. This factor will increase the yield up to 3x. So how farmers can increase their yield by just simple application of cobalt in terms of foliar application, or in terms of irrigation. We can increase eventually our yields by 3x factor. When a fruit is stored for an extended period of time, such as apples or banana, one of the major challenges with degrading fruit quality storage is due to the effect of senescence, which is plant growth, and ethylene production. When fruits start ripening, they produces ethylene, and ethylene is responsible for their more degradation. When cobalt can inhibit it, and it will add more shelf life to the fruit, and therefore farmers can increase the shelf life, and farmers can get better profits in terms if they increase the shelf life of a fruit. Cobalt is also needed as an enzyme cofactor by Rhizobium bacteria for nitrogen fixation. Cobalt is an essential microelement which is needed by enzyme cofactor for nitrogen fixation. Like there are certain legumes which tends to fix less nitrogen, tends to fix naturally less nitrogen in absence of cobalt, or in a not sufficient level of cobalt, and this can lead to like their suppressiveness towards nitrogen fixation. Cobalt can be present in many oxidation state, but used by plants only in its reduced form, and this reduced form is not easily available, cause our traditional management practices, when we apply glyphosate, or when we apply salt soluble fertilizer, or when we apply high doses of herbicides and pesticides, this unoxidized or reduced form of cobalt is not available, and it's not available in the plant available form, and therefore it will not be used by plant, and therefore plant cannot actually profit a farmer, and that's what it is. Interplanting sweet asylum Lobelia maritima for aphid control. This is actually a biological agent or biocontrol method, and this research is quite helpful in terms of achieving good yields. The root cause of aphid to feed on certain plants, that their carbohydrate profile or their plant sap is actually digestible by these insects which they depend on for the feeding, and this profile is dependent critically on mineral plants require as an enzyme cofactor to develop functional enzyme system. So this actually the plant take up certain minerals, and within the absence of those minerals, plants cannot actually develop certain carbohydrate profiles, and which tends to make them unhealthy. And this insect, or this sap sucking insect, eat on those plants, and they become disease susceptible. And this mineral profile is dependent on soil's biologies to supply these nutrients. So if soil is a good, like soil is biologically well sufficient with minerals, these minerals will be abundantly available to plant, and the plant will be overall healthy. But our management of field ecosystem, which are traditional management practices, which are really unhealthy and which are degrading the soil, will allow the aphid to proliferate. They actually will increase the aphid population, and they can cause a really great damage to a farmer. Our management of our field ecosystem that allows aphid, we tend to supply them with abundant food source and no habitat for the natural predators. When we apply insecticide, their natural habitats or their natural predators will get killed, or they get they fly away from the field. And after application of insecticide, we improve the environment for aphid by not actually control them, but by increasing their population. As we remove all the natural predators, and will weaken the plant even to further extent. Therefore, interpreting sweet asylum in lettuce and broccoli as a biological control for aphids. This can attract hoverflies to attack aphids. Hoverflies usually feed on aphids, or they lay their eggs in aphids so that they get killed, and basically they limit the aphids population. How this can impact on crop yield? This is an eminent practical and scalable biological control with a solution for aphid pressure. An estimated range of 500 to 1000 plants per acre can provide an effective control against aphid. Now, there is this research which says that coronavirus cure rate in which selenium status play an important role. So selenium is basically metalloid, and how its status plays an important role. The link of this dietary selenium and output of COVID-19 disease. Selenium is an essential trace element which is a metalloid obtained from diet of fish, meat and cereal. Selenium efficiency could be useful to reduce disease susceptibility to enveloped viral infections. What are enveloped virus infections? Sorry, these are basically infections in which the virus is actually covered with a lipid membrane, and that's why it is called as an enveloped virus infection. So, influenza and COVID-19 are enveloped virus infection have been around world for a while, but vaccines are still effective against them due to their rapid mutation rate. We can have collective desire to develop preventive approach based on producing food and medicine scale and ensure that all crop plants have generous levels of selenium as Finland did. So there was the study which says that Finland actually increases their selenium production or selenium content in their grains or in their veggies or in their fruit, fishes or in their soil by, and this actually helped them to eliminate or to get suppression over the COVID-19. It is well known fact that selenium deficiency both in agriculture, food products and in humans is associated with various degenerative diseases, notably viral infections. This selenite is an effective treatment for enveloped viruses, which viruses contain lipid around their membrane. Finland made a systematic effort to increase selenium levels in their soils. Farmers can have a bigger impact on public health than all doctors and hospitals combined growing nurtures uh, because of growing food and medicine which can be preventive against and which can stop us from getting it. Adding sodium selenite or sodium selenate 15 grams per hectare can give an optimum selenium content. This can help to this can help us to decrease our disease. This can help to decrease our disease susceptibility towards enveloped viral infections. And how nutritious food which which is grown by farmer, which is rich in every trace amount of mineral nutrient required by our body, and which can actually tend to build our immune system or tend to build our gut even stronger, and how that can be really helpful. Now the next research is actually electrical conductivity comes from biology of a healthy soil, how EC can influence productivity, and how EC is responsible for generating higher amounts of heat, and how this EC is actually generated from a biology of healthy soil but not from a biology of an unhealthy soil. To grow crops that are high yielding and healthy, soil needs minimum electrical conductivity of 200 Siemens per meter during their germination stage, and during their fruiting stage we require it from 600 to 800 Siemens. Plants don't grow from nutrient, they grow from the energy which are provided by these nutrients. And how nutrients are basically absorbed by plants is with the help of electrical conductivity. Traditional agriculture provides the electrical conductivity in soil by adding ionic salt fertilizers and that have electrical conductivity, and thus increases the EC, where this salt fertilizers oxidize the microbial population, age the clay and actually damage the soil aggregates. How? When we apply the salt fertilizer, they will actually kill the beneficial microbes which are responsible for keeping the which are responsible for keeping the gut gut of a plant healthy or immune system of a plant healthy, which also tends to lead to natural disease suppression. And this salt fertilizers age the clay, degrade their quality, damage the soil aggregates. Where in biological soil, the electrical conductivity comes from microbial cell. When they come biological from this microbial cell, they provide an abundance electron flow through the soil and produces much higher yields and higher quality of crop as well. So how? When we generate EC from biological soil, that will intend to provide abundance electron flow through the soil, and that will produces much higher yield as compared to that of the traditional practices. So that was all about this video. I hope you guys genuinely like this video, and if you do like it, please do share and subscribe to this channel. Thank you.